When a massive star reaches the end of its life, it attempts to trigger a supernova, the most violent explosion in the universe. But for decades, computer models simulating these events showed a disturbing failure. The star's internal engine would suddenly die, and the explosion would stop. If the engine remains dead, the iron, oxygen, and carbon forged inside the core are lost. Gravity pulls them into a central point of no return, where they are swallowed by a black hole forever. This 1985 paper describes the stalled supernova shock, a phenomenon where the math simply couldn't get the star to shatter. In the simulations, the outward-moving shockwave would freeze and then begin to collapse back on itself. The solution came from physicists James Wilson and Hans Bethe. They identified a specific mechanism that could jumpstart the stalled engine at the final microsecond. They proved the supernova doesn't happen in a single burst. It requires a hidden, secondary interaction to push the star past the brink of failure. For millions of years, a star maintains equilibrium. Outward pressure from nuclear fusion perfectly fights the inward crush of gravity. But eventually, the star forges iron. Iron fusion absorbs energy, so outward pressure vanishes, and gravity suddenly has no opposition. Gravity crushes an iron core the size of the Earth into a city-sized sphere in less than a single second. The outer layers of the star fall inward at a quarter the speed of light, smash into this new ultra-dense core, and violently rebound. This rebounding shockwave is the force that should tear the star apart, but almost immediately it hits a wall of falling matter. The newborn shockwave fights to move outward, but it is plowing through the millions of tons of stellar atmosphere that are still raining down toward the center. It loses momentum quickly. The wave is exhausted by the effort of tearing apart heavy iron atoms and fighting the sheer weight of the star's outer layers. At roughly 150 kilometers from the center, the outward push fails. The energy is spent, and the wave completely stalls. Bethe and Wilson's data highlights just how dire this moment is. Between 0.45 and 0.47 seconds, the shockwave actually recedes, moving backward as the star begins to win the battle. At this moment, the explosion is dying. The star is on the verge of becoming a black hole, unless a new energy source can intervene. The rescue comes from deep within the star, where the newly formed proto-neutron star is struggling to shed its own heat. The core is so hot that it begins to release energy in the form of a torrential flood of subatomic particles, neutrinos. Neutrinos are essentially ghostly. Under normal conditions, they pass through solid matter as if it weren't there, traveling through light years of lead without ever touching an atom. But the plasma directly behind the stalled shock is incredibly dense. A tiny fraction of neutrinos are actually absorbed in this gain region. This trapped energy superheats the plasma, creating violent, boiling convective plumes that push outward. This injection of thermal pressure is the hidden force required to re-energize the stalled shockwave and finally blast it back into motion. The boiling pressure kicks the shockwave back to life, blasting it through the rest of the star's layers with renewed violence. In the extreme heat of this revived wave, a second stage of fusion begins. This explosive nucleosynthesis is the only place in nature where elements like gold, silver, and uranium can be forged. The shockwave finally reaches the surface, ejecting the star's outer layers into deep space at thousands of kilometers per second. Without the ghostly intervention of the neutrino, these heavy elements would have never been created, and they certainly wouldn't have been scattered into the cosmos. We see the results in supernova 1987A's star field. First, the pre-explosion sky. Then, the shockwave's light arrived, proving the engine revived. Finally, we're left with complex rings of newly forged elements, the debris of a star that nearly failed. These expanding remnants eventually seed the nebulous where new planets and solar systems form. Because the iron in our blood and the gold in our hands were created in these final moments, we are all star stuff. And we only exist because a ghost particle saved a dying star's stalled heart.